Alright, dear children, welcome back to the class. In this video, we'll discuss about displacement time graph. You must have heard both the words. One is displacement, another is time. So let us discuss about displacement time graph. These are also called as ST graph. Why it is called ST graph? S means displacement, right? So the meaning of S is displacement, that is a symbol, and T means time, so that's why it is displacement time graph. All right, so usually in physics, on x-axis what we represent? We represent time is always there on x-axis, please remember this. And on y-axis we are going to represent displacement. So this is what displacement time graph is. Now for example, first case is if body is at rest. Body is at rest. All right, body is at rest means, it is not at all moving. Its displacement is not changing. If it's displacement is not changing means it is at rest. Now look at this. This is the graph. For example, if you take this and analyze this, here time is passing. For example, time is 1 second now, 2 second, 3 second, 4 second. Time is changing, but look at this displacement. For example, if it is 4 meter, now 4 meter it is fixed at 1 second, also 4 meter, at 2 second also 4 meter. When it was 3 seconds time, I saw displacement was 4 meter. Again at 4 second also displacement was 4 meter. So everywhere displacement is same, right? In this scenario, look at this. So that's why this is the graph for body at rest. So if in the exam you are being asked to draw the displacement time graph for body at rest, then you should be able to draw this graph. So this is the first one. Now body is at rest means what is the velocity? Velocity is also equal to 0, of course. If velocity is 0 means acceleration is also 0. Okay, so those things, see, body is not at all moving means velocity will be of course 0, then acceleration is also 0. Okay, that is the analysis of body at rest. Now second graph is body in uniform motion. Body in uniform motion. You understand the meaning of uniform motion? Uniform motion means body will be covering equal distances in equal intervals of time, no? Yes or no? You know the meaning of uniform motion, no? Equal distances in equal intervals of time. Equal intervals of time, then only body is said to be in uniform motion, no? Then that graph is obtained like this. Okay, this is the time axis, this is the displacement axis, then I'm going to have the graph like this. This is the straight line. I will have the straight line here. So how to analyze this? Now look at this. For example, this point to this point, now this is like let us assume 0 to 1 second. In that it has moved 2 meter. I'm taking an example. Then in another 1 second, 1 to 2 second, again I have observed, now it has come to 4 meter. Now look at that. In 1 second, how much it has moved? 2 meter. Now in another 1 second, how much it has moved? Another 2 meter. Are you understanding my point, what I'm trying to say? 2 to 4 means another 2 meter, no? So in every 1 second, in every second, body is moving 2 meters. So then definitely this is the case of uniform motion, right? You can have the definition here. So equal distances and equal intervals of time. What do you mean by equal intervals of time? Here in every second is equal intervals of time. Moving 2 meter is equal distance it is, right? So this is the case of uniform motion. No need to draw all these points and all. You can just draw. How you can draw? You can draw one straight line which is passing through horizon. All right, so here is the graph. This is the time axis and this is the displacement axis, and the graph comes to be like this. This is a straight line. So this is the graph of body in uniform motion. All right, now body is in uniform motion means how about velocity? Velocity is constant or not, dear children? So this graph is also example for constant velocity. Are you getting my point? Uniform motion means velocity is not changing, then only, if velocity is not changing, then only it is able to cover equal distances in equal intervals of time, no? So that's why body in uniform motion means it is having constant velocity also. And how about acceleration? Acceleration is equal to 0, because what do you mean by acceleration? Rate of change of velocity is called acceleration. Here velocity itself is constant, means acceleration will be 0. So this is the example for body in uniform motion. Now let us try to understand third one, that is like a body in non-uniform motion. Non-uniform motion means everybody knows it, no? Non-uniform motion means, I mean, body covering equal distances in unequal intervals of time, or unequal distances in equal intervals of time. No, the such graph will come like this. For example, this is the time axis and this is the displacement axis. So here is time and here is displacement. That graph comes to be like this. Yes. So now, I mean, initially look at this, I mean, time has passed here. Okay, time has passed here, but displacement hasn't changed. But immediately displacement has changed. Suddenly it increased, suddenly it kept on increasing. So this is an example of non-uniform motion. Now what do you mean by non-uniform motion? I mean, I told you the definition of non-uniform motion. Now this is variable velocity or not? This is not constant velocity. If constant velocity was there, then it would have been uniform motion. This is variable velocity. If variable velocity is there, means acceleration will be some value. Acceleration, I mean, definitely it will come. I mean, acceleration is, I mean, it is not equal to 0. Okay, it will, acceleration will have some value, that to some positive value it will be having, because velocity is changing here. Velocity may be increasing also, velocity may be decreasing also. If velocity is increasing, means acceleration will be positive, and if velocity is decreasing, means acceleration will be negative. All right, so these are the things which you should be knowing in displacement time graph. I hope you understood all these things. Thank you very much. Have a good day and bye bye.